TPA3255 SAMP-200 board. This is a third board that I'm reviewing. I'm selecting some interesting China manufactured boards, and why I'm choosing currently China manufactured TPA3255 boards, because those are really investing in this direction, creating number of small size amplifiers and somehow accumulating knowledge to build really small size well priced boards. And this one drew my attention because it's using two TPA3255 chipsets, each per channel, and this means it has a better thermal performance, and also it is squeezing maximum out of the chipset, because in that case it's kind of 2 ohms rated, and especially for 4 ohm solutions this is very good approach. Then you have 2 chips. For 8 ohm loads or for 8 ohm speakers it's fine with 1 chip and 2 channels in BTL configuration. But this is for lower impedance speakers, or those who have some issues with a crossover. Once you can go down to 2 ohms, it drives any speaker with confidence. There are 2 versions of these boards. One with automatic wake up from signal function, and it costs you extra 10 euros, or simple 2-channel amplifier, which you can use together with a good preamplifier or digital to analog converter. This board drew my attention because it has additional power converter, creating plus minus 12 volt voltage to drive buffer operational amplifiers. And this is an important thing because for a professional application there's requirements that any amplifier preamplifier should be capable of plus 20 decibel non-distorted input. Plus 20 decibels means 10 times. So if the maximum operation voltage or the input signal what you need is 1 volt, then with 10 volts it should also be unclipped. And for that you need higher voltage supply. You can't work with just 5 volts or even 12 volts are not sufficient. You need a plus minus 12 volts, and this for operational amplifier gives exceptional linearity. So the buffer stage for this amplifier has some advantages over others. No, in reality it's a minimalistic advantage, but anyway, all operational amplifiers is plus minus 12 volts is working better than just a single voltage like 12 volts. And then you need a number of blocking capacitors. If you use dual voltage, then you don't need a blocking capacitors. It is easier to build all the system. I also checked some critical components, and important component is output inductor, especially when you're putting in parallel bridge configuration and 2 ohm rated. It should be high current rated inductor, and it's here. And also important, you need powerful filter film capacitor, and those are nevertheless those are budget inductors. Those are good ones for that particular application what we have here. In promotion, this company took screenshots from company Sagami, and this is Sagami code for those inductors, but those are not Sagami inductors. Those are China inductors, but I'm pretty sure those are good ones, because it's not very difficult in our days to really make a good inductor if you have all patterns done by others. You can see that Sagami has a different type of coding, no, like that one. And Sagami is a well-known Japan company producing inductors for Class D amplifiers with very low distortions, and there is kind of a replica of that. I was trying to find this EPCorp brand, but I didn't found, so it's just a name somewhere. Probably those inductors are manufactured in large factory, and then everyone can brand it as they want. But there is company EPCOS, now part of TDK, Japan company, also manufacturing inductors, and I think this is kind of sounds somehow similar to EPCOS. EPCorp, EPCOS, but this is marketing. This is marketing. And a couple of things which are important for inductors. And if you look at this board, yes, there are 100 microhenry inductors with the same parameters as Sagami. This is a Sagami datasheet. And we have this A and C version, how much I can see through that small hole in inductor. A high quality sound is realizing using oxygen-free copper wire. No, when I checked oxygen-free technology, all copper is developed with oxygen-free technology. So it's just a normal copper wire. But anyway, those inductors are very good. Those inductors are very good. And what we see, it has low resistance. If you're really at extreme, but it's not our case with TPA3255, then we can have a flat wire winded inductor, and then we can almost double output current or reduce inductor internal impedance to 9.2 milliohms. But normally 15 is fine, absolutely fine, and we have a high damping factor using that particular inductor. It's a good. Also important for 100 microhenries, we are capable up to 26 amps. And TPA3255 amplifier in most extreme case can go maybe up to 15 amps, but this is a really extreme case with a 2 ohm load and many other things. And also temperature rise above a current, and this is like a constant current through the inductor, but we have audio signal. Audio signal has a crest factor of 8. That means that maximum power divided by 8, and this also parameter is very good. They will be just a ohm. So great inductor chosen for that particular board. One more thing really to look, and our case it is 10 microhenries, and you can see how quickly things change. For example, if you have a higher magnetic performance inductor, that ferrite core is saturated at that low current. I would say we could work up to 3 amps, and in that case that size of inductor will be too small. And by dropping that inductivity, the saturation current rapidly grows. In our case, we can go up to 26, up to 30, and core is not saturating. So at any load, we will have a perfect filter at the output. Right inductor chosen. And now let's inspect a real board under a camera and look at those theoretical things and try to find out what we can get from this particular board. Okay, let's inspect the board. And you can see I prepared it for a test already. I did all necessary connections and some brief visual inspections. What we have: input connectors, I would say pretty low quality. It's a mild plastic, and they are mechanically are not strong, but it's completely fine if you make a project and one time just interconnect, then everything is fine. But generally speaking, those are on budget. Then here, this part forms plus minus 12 volts. There's a special converter, and this is specific of this board because this plus minus 12 volts, your input circuits theoretically operates better. It simplifies in some sense input circuits as well. Then we have our inductors, what we already discussed, and the key difference between let's say expensive and non-expensive is some additional stuff against the vibration, because under the high current in a ferrite bed or in a ferrite cover, how those inductors are made, they will move and can be audible. It is not with the audio signal, but if you put some specific high current sine wave or complex wave, you can find out a moment when they start to give some noise. It doesn't influence audio quality. For audio signal everything is fine, but just for example, if you use it for a spacecraft or aviation, those small things sometimes play a role, and then they put special compound or a special glue together with thermal conductor, and then they secure those windings inside that they will not vibrate. 2 heat sinks. Of course, I disassembled and checked are there sufficient thermal paste, and there is it is well made in that way. They have sufficient thermal paste, but some things what I don't like, I would prefer if inside there would be spacers that you tighten screws and you have some pressure from the board to really have a best thermal contact. Here it is done by the depth of the thread, and it's not precise process, so I still don't know. Either they lands and somehow have a good pressure to chip or not. Generally, I'm not very happy with this thermal solution. Hopefully it's okay, but there was a way to make it better. And if I look to dimensions, it's relatively large board. No, roughly saying 130 to 140. It's large board, and I was thinking how to position it, and I have no clue. It's pretty large board to integrate somewhere. It's meant for a passive cooling. That means this vertical placement is the best. You can put on the back of the speaker, but otherwise not easy to implement. If I put in a separate box, it'll be kind of large box. For me, it's hard to position. We will measure and then we listen and then I give some final conclusions. But overall, board is interesting. And let's inspect input circuits. There are some specifics. I will take a microscope and then we look under the microscope. And there is a specific. There is no DC blocking capacitor. Once we have dual polarity power supply for input circuits, we can do it, but there are pluses and minuses. And how those circuits are made? For example, here is 1 kilo ohm input resistor. So input circuits going through this 1 kilo ohm. There is 47 kilo ohms to the ground. This resistor determines input circuit impedance, and impedance is high, 47 kilo ohms. It's very easy to drive this buffer circuit, and then it goes to op-amp non-inverted input to the third pin. And those two resistors, those 330 ohms and 1 kilo ohm, those determines input gain. And input gain is set for 3 times. That means 330 millivolts input will give you 1 volt output, so it has improved sensitivity. You can drive with a low output circuits, and it could be important when you're using budget digital analog converters which are fed by 5 volts. Then your maximum output in unbalanced configuration is 2 volts, and then you have some headroom and you can really drive this amplifier to the max. So generally good circuits, but in forums I read that some guy said that this is very bad board and it doesn't sound good, and when I thought why it is, because it's not true, this board sounds awesome. One of reasons could be that since there is no blocking electrolytic capacitor at input, and you are using some budget digital analog converters or even computer outputs where also you don't have blocking capacitor, and you have, for example, 2.5 volts at output, those will be also amplified, and then your buffer circuits will not work well. If you have problems, measure output DC of your source, and if you have problems with that, then you should artificially add this blocking capacitors of 47 microfarads, and then everything will be fine. So they really worked to improve low frequencies since there is no this blocking capacitor. Those are small things, but those are not described in description of this board, and you should be aware about it. This board is using TL072 operational amplifier. For those who like to change input operational amplifiers, designers are using TL072 op-amps, and those are op-amps excellent for this particular input configuration. And I would say that when you swap op-amps, you should really understand what you do. And I will show some parameters what you should be aware about it. And my recommendation, leave it as it is. Okay, one of the benefits of this board is high input impedance, and they use this chipset, and it has some specifics. I would like to draw your attention this input capacitance. Actually, it refers to input impedance of this specific op-amp, and you can see 100 mega ohms. It's very, very high. So you can build, you can drive this op-amp with extremely small current. So any source will drive this particular op-amp, and this is a good thing. And designers reduce it to 47 kilo ohms, and 47 kilo ohms for audio equipment input is a very good parameter. And how it is achieved? It is achieved by MOSFET internal structure. This particular op-amp is different. It's very good as a buffer amplifier. It can't make huge current at output like any 5532. Otherwise, it's great operational amplifier. You can see that small signal total harmonic distortions has a triple zeros, and it is so good, so good, so good. Those who are hearing difference between operational amplifiers, I doubt. No, you can't hear those differences. Probably if you exchange in like this particular case, you exchange with different operational amplifier, you get a coloration. You get a coloration. Because then you need different parameters of those supplementary resistors which are making that gain and other stuff. My recommendations: don't swap operational amplifiers. And now let's measure that board. Okay, now you see oscilloscope, and I will put some arbitrary signals and we will check. And the first thing, we just look output signal. Yeah, it's absolutely great, nice output signal. So everything is connected correct because those are in a phase. And first thing what I want to check is frequency response, or at what frequency this filter has been optimized. I will give a sweep, 20 to 20 kilohertz, and we will look it at 8 ohm load and at 4 ohm load. Okay, here you can see here is a sweep, 20 to 20 kilohertz, and you can see that on 8 ohms we have some little bit peak, and then 4 ohms it's almost ideal. So this particular board has been optimized for 4 ohms. I think it's right approach, because when you set in a bridged parallel configuration, so with the capability to drive 2 ohms, we are aiming our board for low impedance. So, and then it's better to optimize not for 8 ohms, but for 4 ohms, because for 8 ohms we can use single chip solution, that will be fine. But for 4 ohms, this parallel bridging configuration is a perfect, especially if you have a 4 ohm speaker, then this board is kind of for you. And one more thing, what we discussed in the theory, when you're using budget inductors under the high current, they will move a little bit and you will hear it. You will not hear it with a real audio signal, yeah? Those will dead silent. But when I put such complex burst type of signal, they will start at certain frequencies internally little resonant. It's a small noise what will come from inductors. I will put my microphone close to those inductors and you will hear it. Is it a drawback of this board? Absolutely not. It doesn't influence sound quality at all. But as I mentioned, in aviation you can't use it. You need to have a little bit better inductors. Those are 3-4 times more expensive when you really deal also with those little potential windings movement under the high current. This is a high current situation, and you hear it. Also, we can look at a wider bandwidth, how filter behaves, and I will put sweep now from 20 Hz to 100 kHz. Here I put a large bandwidth, 100 kilohertz, and this is 8 ohm load, and you can see that in 8 ohm we have kind of peak. It's okay. It's a correct way how to tune your filter, and at 4 ohms you can see it's smooth and perfect. So this particular board has very good output filter. Actually, it's a very good picture, and it is tuned for 4 ohms, and this is a perfect picture how it should be. Yeah, 8 ohms, 4 ohms, 8 ohms, 4 ohms. Or if we put it at a larger picture, 8 ohms, 4 ohms. And can you run it without load? Normally we are not running because we always has speakers connected to our system, but then it's a huge peak, and this is not correct way how to use it. You always should load filter with a load. This is 4 ohm, 8 ohm, 4 ohm, 8 ohm. When we put the 20 kilohertz bandwidth, you can see on 4 ohms it's perfect. And this is audio signal. When you have a good preamplifier and good source at the studio level, it is always filtered up to 20 kilohertz. There is no components above it, and so you shouldn't care too much about 8 ohm or 4 ohm scenarios. When you have kind of filter peaking, it doesn't influence sound. And actually, I would say some specifics of this board is very good output filter components. It's fantastic. Yeah? It's fantastic performance of the output filter. You will have nice, neutral, perfect audio signal out of it. Especially on 4 ohms, yeah, it's almost the perfect replica. And when I listen at this particular board, it has excellent neutral sound out of it. The sound quality was awesome. Let's check one more thing about low frequencies performance. I will put 100 Hertz ramp signal. Here it is, and it has absolutely excellent linearity. So low frequencies will be perfectly fine and precise. Also with a 2 ohm load capability, your bass will be punchy precise. And let's look at the 20 Hertz. So now we have 100 Hertz, it's perfect, and let's put it 20 Hertz. Minor changes, almost perfect. That at a low frequency this board performs awesome. But when we talk about the theory, you know that there is no coupling capacitor or DC blocking capacitor at input, and this is why it's so good. So you should consider your application scenario and source. If the source is made properly, there is no problem, but if source has some DC output, and many cheap preamplifiers has DC at output, then you need to add additional blocking capacitor to make this board work properly. And how about 10 Hertz? Because 10 Hertz is not what we want to measure. For sine waves, this is perfect, but just for curiosity. And even for 10 Hertz, it's excellent. So input circuits with plus minus 12 volts, those are awesome. And this is strong point of this particular board. And those who are looking for a maximum unclipped power, let's make experiment. And I have 42 volts power supply. How much unclipped signal we can get out of this board with a 42 volts power supply, which is a maximum what you can use in a passive configuration without fan. You can't go for 48 volts for this board. It is overheating, because even at open environment I tested at 48 volts, it relatively quickly reaching 60 degrees temperature. When you put in a box, it's 10 degrees more, and this is 25-degree environment. If there is a hot day, then you are in trouble, or we really will be running at a maximum power for a home party. No way. So maximum voltage what we can use is 42 volts. It's clear with that particular heatsink size and the way how it is made, you can do passive 48 volt applications. And okay, let's try the maximum what this board can. So we are looking for reading 2, and currently we are at 10 volts. I will put a maximum where it start to clip, So we can go up to 29 volts, and this is without load. I will put at 8 ohms. Yeah, it's perfect. At 4 ohms, we can go a little bit lower. Oh, up to 27 volts we can go. Yeah, up to 27 volts. This is RMS value. So 27 volts. Let's calculate how much power we can get. And with 42 volt power supply, we can get 182 watts, clean watts on 4 ohms, and this means about 90 watts on 8 ohms. So great 200 watt amplifier. Yeah, peaks you can get even more. But I personally would use it with a 48 volt power supply and active cooling, because the size of the board is large, and why not to make maximum out? And we will think how can we make it. But in a passive way you can use 42 volts. Yeah, that's the right approach. And then you get in a 4 ohms 180 watts, and those are good watts. It's very good amplifier. It's high power amplifier. It can drive any home system, 4 ohm home system what you have, 3-way, lousy built, crossover. It will shine. It will shine. So, and some summary. And the first question about audio quality. I did also listening tests with the 4 ohm speakers. Board audio is awesome. It's fantastic. It's perfect. It is 4 ohm speaker optimized. Will it sound good with 8 ohm speakers? Yes, they will, because the difference is really small, but it is perfectly optimized for 4 ohms. And this is the right approach, because once you are using this parallel bridged solution, there are 2 chipsets, yeah, parallel bridged solution, and those are 2 ohm compatible, then it's logical that you use a 4 ohm speakers, get maximum power out of it, and even working with bad designed crossovers, this board will perform. Audio quality is perfect. How about the filter quality? You hear it, that there are some resonances. Those internal windings are moving under the large current, but for normal audio signal, those are perfectly silent. You can't use it for aviation, as I mentioned, when vibrations are an issue. But definitely those are budget inductors, but those budget inductors, those are very good budget inductors, because the output filter quality is fantastic, as you see with the tests with arbitrary signals. So with audio everything is fine. How about the thermal? With the thermal I have complaints, and this thermal solution is so-so. And definitely what I will do, I will remove all heat sinks. I will change the thermal paste for a maximum. And the key problem with that is for a best thermal performance, you need chip and heatsink surfaces perfectly parallel. And with such kind of solution you can't make. And if some of you have seen graphic card boards, then they have the same heat sinks, and then from the top there are 2 screws with a spring, and then you load with a spring, and they automatically leveling, because you can't make with a soldering perfect parallel system with such kind of heat sinks. What I will do here I will put some rubber rings from plumbing industry. Yeah, for the tips there are such insulation rings from a good material, and then they will work as a spring mechanism, and then I will tighten and be careful with that there is a kind of some pressure coming from the rubber which could play, and then those small things will be fixed, because you know how work that thermal paste. So normally the best heat dissipation or heat transfer happens when both surfaces are parallel, the chipset and heatsink, and heatsink is good. Thermal paste is filling only small scratches, somehow improving that total surface what they're touching. Not that a huge amount of thermal paste will help you. No, you just need to feel micro gaps between those two metal surfaces. But metal surface is the best to transfer. And when it is really thin, and you can do it, and those are parallel, then your heat dispatch is best. And I read in forums that someone bought this board and then it was overheating, and then even one channel has been damaged. Everything comes with that heatsink design, or this thermal design. Unfortunately, you need to improve. I will do it for that board. When you do it, then it's great. Can you use it with 48 volt power supply in passive way? No, you can't. 42 is the maximum, because otherwise all those components will overheat, and even at pretty comfortable temperature they are reaching 60 degrees, and 60 degrees is a marginal. When you put in a box plus 10 degrees, and when you have very hot weather, then even plus 10 degrees, and then those electrolytic capacitors will suffer, and many other stuff. You need active cooling when you want to go for 48 volts, or make it vertical and make a chimney. But this is large board, and then it's bulky solution. But if you put in a box and put it vertical, then you can go for 48 volts, providing good airflow. What else you can do? You can put a large fan. This is a 140 millimeter fan with a low RPMs. It will be silent, well designed solution, and then you can use it as a separate device. But then you need also for a fan 12 volts. And if I say what we are missing in this board when we have such type of passive cooling and maximum power, how it is rated. I'm not talking about the 600 watts, I'm talking about the 250 watts maybe maximum. Then it will be great to have a 12 volt fan management output for this board. This board is large and there is sufficient space to make it. Board quality is so good that I decided that I will put in a box. And what kind of box I will use? I have such type of universal boxes. I also had in my shop for that, and this is almost perfect for this particular design. And then this amplifier has a good thermal management with a forced air cooling. It has all outputs, and those inputs I will replace with a RCA, make a data adapter, and then I have a pretty good solution. Could we fit in it if I put board like that? Yeah. So here I have a fan, that I have a good airflow, and then I can have nice small 450 watt power supply, and this will be awesome solution. This is LLC power supply from Meanwell. This is medical grade power supply. I had a separate video about this power supply. And then this is a awesome solution, fantastic solution, where you can get 260 watts, perfect, super clean power. Yeah, and some headroom up to 300 watts. And this is like equivalent to very expensive amplifier, and audio quality is perfect. So I will put everything together, maybe make some video around, maybe don't. Just I will put in such a box, and it fits well, and it will be just a good amplifier. And then I will sell it for reasonable money. And for those always question, could you recommend this board? If you want a great audio quality, and knowing all the lowlights of this board, what it has, the strong point of this board is audio quality, because those plus minus 12 volt input circuits really working well, and you have tons of headroom, and this is responsive. No complaints. It sounds like very expensive audio amplifier, but it's still TPA3255 amplifier. Will I make kit or something for such board? No, too much additional manpower is needed to use it. And I also would say that, guys, let's make version 2 and put small things in it, and especially work on a thermal solution of that. The only real significant complaint for this board is a thermal solution. And with the size, no, difficult to implement, but it sounds fantastic. Yeah, it sounds fantastic. And don't trust guys who put in forums comments that sound is bad and something else. No, sound is good. You just need to understand all those things. And as I mentioned, if you have DC output at your preamplifier, then you need the blocking capacitors, and recommended blocking capacitor is 22 microfarads. But if you have a good preamplifier where is no DC in output, then you can leave input circuits as they are. Good luck with your projects.